Here we are at Microsoft in North Ryde, and we're here with Stephane Budo. Hello, Stephane.
Hi, Mark.
Do you want to introduce yourself?
Hi, I'm Stephane Budo. I'm a Microsoft MVP, Azure Solutions Architect, and a Director at Vigilant IT.
Excellent. And so I've got Stephane here to talk about ExpressRoute and Microsoft peering.
We got great Microsoft mugs.
Awesome. And I've got Microsoft coffee as well. Fantastic. So Microsoft peering, what's the date today? It's recorded 2nd of August 2018. Mm-hmm. So 1st of April, what happened? Microsoft took public peering off the availability list. Can't set up public peering anymore. Mm. So that confused a lot of people because public peering the natting was different to Microsoft peering. Now that Microsoft peering is on the price list and you can deploy Microsoft peering for Azure Public and Office 365 public prefixes, then the natting's somewhat different. And it's confusing a lot of people. So this is why we've got Stephane Budo here today to talk about, basically make sense of all of this.
Absolutely.
Are you happy to draw this up on the whiteboard?
Yeah, absolutely. Take a step back though first, and for the people out there that very quickly don't know what ExpressRoute is, to connect to Azure, basically, in your private environment, you can either connect via VPN, which is the traditional VPN methodology, or use ExpressRoute, which is kind of comparable to an MPLS private network in the other worlds out there. Right? So you're effectively creating a private connection from your data center to Azure using a third-party provider. So you need that third-party provider to be there in your data center, in the Megaport, Telstra, Vodafone, etc., to establish that connection, that private connection. That's what ExpressRoute is. It gives you better latency, guaranteed bandwidth, etc., compared to VPN, who doesn't because it goes across the internet.
Yep.
So in the Express world, there is three types of connections. There was three types of connections. There's the private connection, which is called private peering. There's the public connection, which is called public peering. And there is the Microsoft peering. Right. So the difference between the three, private peering is you have your own data center with your own set of private IP addresses in the 10.172.192.168 range.
RFC 1918 address space.
There you go. Oh, wow. Very impressive, Mike. I did not know that. Anyway, so you get your private IP addresses, you have your private vNets and subnets within Azure. You want to connect the two like you would with a VPN. You create a private peering.
Yep.
So it's got nothing to do at that point with public IP address. It's all private. Yep. And it's all a private connection like an MPLS would be.
And it goes to a vNet in Azure, which is completely private and locked off, and it doesn't have to have any access to the outside world.
That's exactly right. So that's the private peering.
Yep.
Right. Now, what the other two were, and I say were because now public peering you can't have anymore.
And some people have got public peering still. Yes,
because if it was established, it will stay established, but you can't create a new public peering anymore since the 1st of April. So public peering, what's that? It's basically saying, well, you got a whole bunch of public accessible services within Azure, storage, SQL databases, etc., public websites,
Azure files,
the portal, everything else is accessible through the public internet, so public IP addresses. What public peering does, it's allowing you to use your ExpressRoute circuits, which can be very large, 10 gigabit for example, to actually access those public IP addresses. So instead of from your on-premises or your data center, instead of going out on the internet and accessing those services through the internet, you go out through the ExpressRoute. So this is purely done by routing. Right? So that's how public routing was.
But there's another part of this as well, where because it's public, you've got to be careful about advertising certain ranges, because then if you advertise the same ranges through public peering versus your internet peering, then you can have asymmetric routing and things like that.
Well, yes, and we'll come back to that in a minute. So luckily, public peering is now gone, so you can't do public peering anymore.
Yes.
You have public peering has been merged in, I'd say, inside of Microsoft peering. Now, what Microsoft peering was before this merge was the same as public peering, except to access Office 365 services. So your Outlook mailboxes, your SharePoint, etc. So that was your Microsoft peering. Now, they merged the two, which is a great thing. Why? Because there's no need to have a public peering to go to Azure services, and at the same time have Microsoft peering to go to Office 365. It just doesn't make sense.
So part of this is, well, now that they've merged it, the other part of it, the natting requirement, having the NAT on the customer side, that part hasn't changed, has it?
Correct.
But the only reason why it's sort of come up now is because of this whole merge of the Azure availability, the Azure public zones through Microsoft
Right.
peering, people are needing to move to it now,
Correct.
and they're all of a sudden facing this issue where they have to manage their own NAT
Let's
device.
just take a step back and very quickly draw up what ExpressRoute looks like
Yep.
in a private environment, in a public, in Microsoft peering environment.
Okay, cool.
So you have your data center, you have the provider, and you have Azure/Microsoft. Okay, so you have a DC, you have a router. Let's not get security involved into this discussion. Let's just purely look at routing. Although, of course, once you go onto the public network, including ExpressRoute, Microsoft or public peering, of course you need firewalls and security around that. But just for the sake of not complicating the discussion, we're just going to leave that out. Okay? So you have a router, and behind that you say you have your 10.1.1.0/24 network. Very simple. You have your workstation here and you're working away, and right now you go on the internet through something else, it doesn't matter. You want to connect this to your Azure vNet, which is private as well. So you go to a provider, Megaport, Telstra, Vodafone, the list is long, and you say to them, look, I want an ExpressRoute circuit. So what they'll do, inside of your data center, where next to the router, they'll drop in literally a physical cable, physical fiber optic cable, that will allow you to have the physical connection to a provider's network, right? So that provider's network is, again, like a backbone from Telstra, from Megaport, etc., etc. That physical cable, so with that physical cable that you then connect there, you establish an ExpressRoute circuit. Now that's two parts of that. The first one is to create within your provider your ExpressRoute circuit, and that will include VLANs at the customer edge and at the provider's edge, right? So that's what we call Q in Q technology, whereby
S-tag and C-tag.
Correct, that's right. Whereby your VLAN, when it leaves your router, will be tagged with the VLAN ID, but when it gets to the actual edge of the provider, it will be not retagged, it would be included inside of another tag.
Which is an S-tag.
The next, that's
Service key in the S-tagger.
correct. Yep. So you end up effectively with a VLAN tag inside of a VLAN tag.
Got it.
Q in Q.
Got
right? Why? So that in here, when the packet traverses the provider's network, it doesn't matter what VLAN you use here. You can use any VLAN that you want, because it's going to get tagged, so they can control what goes across there with the VLAN IDs. Once it gets out of this and connected back to Azure, that tag will be removed from the provider, and then you'll end up with the same VLAN on either side. Okay? So once you've got that connection...
Just so we're clear, so you got traffic comes into here, C-tag, it's overlaid with an S-tag on top of that.
Correct.
And then the S-tag's removed,
Stripped
and then
out,
there's a
so the
C-tag back on here, the same C-tag that was over there, basically.
Correct.
Yep.
That's right. Now, once you've got this set up, the next thing is to set up your Azure ExpressRoute inside of Azure. Mm-hmm. Okay. So once you set up your ExpressRoute in the portal or PowerShell or whatever you prefer to do, you're going to get a service key. Service key is a unique identifier for your ExpressRoute circuit within Azure. You then plug in that service key within your provider that you probably aligned for a portal if they're a good provider, and at that point your circuit is then established from one router to the other router to the other edge. Okay. Now, that's your physical circuit is now established. Well, a logical circuit on top of a physical circuit. Okay. Now, once you have that, it's not the end of the story. Comes into play a little beast that we like to call BGP. Now, if you're not familiar with BGP, this is not the intent of the video to explain BGP, but it's effectively a routing protocol, right? So whereby you can dynamically get routes or send routes out to a router, okay? So now, I've got an IP address range here. I've got, say, 10.1.2.0/24 on this side.
Like an address space of the
An address space of your subnet.
Got it.
We're going to establish a BGP peering between our router here and the edge router in Azure. How do we do that? Well, when you configure your ExpressRoute, your private peering in ExpressRoute, you have to define three things. Number one is, what is my BGP ASN? And I'll refer you to online videos and everything else to explain what an ASN is and how BGP exactly works.
So for private peering, if I can understand correctly, you can't use a public ASN for private peering.
You can, as long as you own it, right? If you don't own it, then don't use it. There are private, in the same way as there are private IP addresses, there are private ASNs out there, which is 64. Don't quote me on this, I know it's on video, but I think it's 63,000 something and above, all the way to 65,000.
Wow.
I think so. Something like that. Don't quote me, go research it, don't use this.
Okay.
So you define your ASN, say I'm going to pick 65,000. You define what your IP address is, your range of IP address that will be assigned to your interface here and to your interface in Azure. Private IPs, it doesn't have to be public. It can be public if you want to, but why use public IP addresses? So for example, I'm going to say, let's go 192.168.1.0/30. Why 30? Because, well, I need two IP addresses.
Yep.
Right? You can assign a /29, a /24 if you want to. Doesn't matter. But only two IP addresses will be used. How is it going to use it? It's going to assign the first IP address,
which is
your router.
Odd number on the customer side.
Yep, .1.
So the way I can remember this is Microsoft is even, because we don't change. Customers are odd. They're popping up and going away all over the place.
We are all very odd.
They're the odd ones out. So odd number for the customer.
First IP customer, because the customer comes first. And second IP for Microsoft, .2. That's not a 2, that's a 2. Okay, so once you've done this, I said there's a third thing that is necessary, and this is, we're not going to go too much in detail, but you also need to provide a range of IP address for your secondary circuit. Now beware with Microsoft and ExpressRoute. For the ExpressRoute to be
secondary
supported
peer or secondary
with an SLA, you need a secondary connection. So you need all this times 2.
So just so we're clear, so circuit is logical, but then you've got two physical connections underneath that. All right.
Yes. So ideally what you do, you go to provider number 1, you go to provider number 2, you get a second circuit, which land on the second set of routers, which land on a second set of VPN gateway, ExpressRoute gateways. Bob's your uncle.
Okay, so in the portal, when people are setting this up, you've got it asks for primary and secondary. The primary is the first physical one, and then the secondary is the second physical.
Second physical.
So here you've just got the primary for this. If you had a second, like a second physical connection,
now nothing prevents you to create a secondary on here. But what's the point? Secondary is there in case something fails. So the recommendation is to have everything in double and even land in Azure in a completely different region.
Right.
For example,
from here, for example, from the provider to us through the MSEE, the edge, it's all redundant anyway.
Yeah.
Yeah, because I've seen some customers sometimes do one connection from here just to the provider because it's.
Yeah.
Or some people do too.
Yeah, but then if somebody cuts off the fiber optic there,
that's gone.
Anyhow, let's not go too deep into this. So let's come back to this. You've got .1, .2. So now you have a set of IP address. Once that is established and you have clicked OK, and the little thing has churned and says, yep.
That's your peer.
From here, from this router, you can ping 192.168.1.2.
Okay.
Because the circuit is established. There are 3 IP addresses. This is where BGP comes into play. You define your ASN, you're going to define a BGP peer from this router to that router and say my peer is .2. Boom, it's established. At that point, automatically, your set of IP addresses here will start to get advertised through here to this router here. And whatever you want to advertise back out from your private, as in this case 10.1, you can advertise it back here so
and
it
you
knows
just set up the advertisement, so vice versa.
That's exactly right. So you advertise your range of networks, Microsoft will automatically, as long as your vNet is associated with your ExpressRoute connection, advertise the range of private that you are using, and everybody knows everyone.
The power of BGP.
BGP is fantastic. So it can be complex, but it's fantastic. Okay, that's private peering. Private. Now the complicated beast. Let's assume for just a second, and I know all the security people out there are gonna, turn around in their grave and go, oh God, what are you doing? Security is not in play here, so please do not do this live. Let's assume here you have an internet connection out of that router. Now, principle of NATing. What is NAT? Network Address Translation. Back in the days, when I was just born, IP addresses that we use on premises were public IP addresses, right? So every device out there that wants to communicate to another device through the internet was just using a public IP address, and everybody is happy. Now, we've run out of IPv4, so people in big company, larger company, millions of devices, start to think, hang on a minute, we can't use a public IP address per device, it's just going to kill us. So how about we create a technology whereby we can have millions of private IP addresses in the background that we can reuse on either side, but then sits behind a device that will translate that IP address when it comes in and requests to go to the internet to one public IP address. Well, that technically is PAT, not NAT, but let's not go into details. You can research that on the internet, I'm sure. So, say for example, I'm sitting here with 1.1.25 and that's my workstation. I want to access www.microsoft.com, which is sitting on a public IP address. I cannot access that with this. I need a public IP address. So comes into play a NAT device, which is a router, which is a firewall, whatever you decide it to be, that will translate that IP address and create a NAT connection to a public IP address. 52.x.x.x. That's going to be used to go out to the website. The website's going to reply back to this device, land on here to this IP address. This device knows that this IP address goes to this private IP address, pops your uncle,
return
you on the
that.
internet.
Yep.
Beautiful. Why do we care about ExpressRoute for this? Well,
here we go.
Why do we care about ExpressRoute? When we talk about private peering, we don't care. Once we talk about public peering, now suddenly we care about NATing. Why? Because all the devices that are sitting inside of your network and wants to access the public-facing services of Azure needs to be NATed somehow. And that is the same thing for ExpressRoute. So how it used to be, say you have an internet connection here, you want to access the public-facing now services of Azure, you would go out to the internet, go out. How do you go out through here until the 1st of April? You would have established, let me put it in red, a public peering. How does that work? Exactly the same principle, right? You go out, you get your circuit, etc. But now, in Azure, when you create your public peering, you have to give the public peering configuration a public ASN. And you get a public ASN in Australia, you go to the APNIC organization, you register your company, you get a private number. So it's a unique number to your company. Mm-hmm. Along with a set of public IP addresses that are reserved for you and you only. Mm-hmm. So there's no conflict out there. So same principle, you enter your normal ASN, 9555. Apologies to anyone out there if I use their ASN, it doesn't matter. And you get a set of public IP address, 103.250.14.0/24. Boom, that's allocated to your company with this ASN number. Mm-hmm. You define that in Azure. You say, this is my ASN, this is my range of public IP address. But you don't need all that. Mm-hmm. Same principle as you did for that. You can get a subset of those IP addresses.
/30.
14.0/30, use the .1 on this side, use the .2 on that side, mm-hmm. and Bob's
customer comes first.
Now, exactly. Now, once that is established, so this, the .2, is not on your private gateway that you've done for private. This lands in the public realm of Azure.
Right, or Microsoft.
Okay? Microsoft indeed, on the private, on the Microsoft Azure public network, mm-hmm. inside of that edge bubble. Okay? How does it all work after that? Well, it's the same principle as what we did with private. It's all through BGP and advertisement. Mm-hmm. Okay? So as a public peering, I'm by default going to advertise the subnet that I use for my peering, advertise it out. What does Microsoft is going to reply to me with is all the public IP addresses that are in, if I do my ExpressRoute as a standard non-premium in my region. So in this case, Sydney and Melbourne, all the public IP addresses used for those services in Sydney and Melbourne will be advertised back to my router.
So just so we're clear, this subnet that you use for peering mm-hmm. with Microsoft, can you use that same exact subnet for advertising?
For public, yeah, sure. You just advertise it, you're done.
Fine.
Here's why. And this is where the tricky bit comes into play. You remember NATing? We spoke about NATing?
Yep.
Now, all the public IP addresses for the public services are now on this router. How do I, with my computer, get to those services? Well, I need to NAT that, right? So what I've been doing, and probably all the customers out there, is use this IP address here that you use for your peering, that is on that interface right here, that goes through for public. Use the .1 and use that as your NAT. And so for any communication, book, I'm sitting behind that and I go out to the public, everybody's happy. Here's the trick. So what Microsoft has done, good or bad, I'm not going to comment, is you're not really using this IP address to access the public-facing services. Why? Because once the packet hits the edge network of Microsoft, there is an additional NAT that is being done. So I go from .25, 10.1.1.25, I get natted to 103.250.14.1, I hit this device, and this device is going to do another NAT with a Microsoft IP address.
So this is public peering.
Correct. Microsoft
Which
IP.
you can't get anymore.
Correct.
But some people do have it.
Some people do have it, which means that this is why when they first established the public peering and had things like SQL databases that they want to access, they couldn't access them anymore. Why? Because now we've got an additional public IP address that we need to add to the firewalls on the SQL as a service. Okay? So if you look at what hits the actual service, the SQL service, and if you search it to a whois database, you'll see that the IP address is being assigned to Microsoft. Okay? Right. So private NAT, double NAT services. Public, bad. Why use double NATing? Who knows, but there's no need because I'm using a public IP address here. I've tested this using private IP addresses and it worked, which proved that they are NATing.
Don't try this at home.
Don't try this at home because they kind of cut us off. Anyway, moving on. So public peering is no longer there.
Right.
But if you have a public peering circuit established today, you can keep it. For how long, I don't know. So we have public peering, as I said. If you have public peering in place, it's still going to work, but you can't establish a new public peering circuit. Good, because we don't need those double NATs. Coming to play Microsoft peering. Microsoft, I can spell peering. See how I'm using public in red, bad, Microsoft peering in green, good. Okay, the difference here is Microsoft peering used to be used just to peer to Office 365. Now it's used to do both Azure Services Public Peering and Office 365, and we're going to use what we call route filters on top of that to filter what is advertised to us as opposed to what we advertise out. Okay, one of the big difference between Microsoft peering and public peering, that is now gone. There is no more NATs. Okay, so Microsoft no longer NATs your public IP address between one of their public IP addresses. The main difference here is that aside from that, you not only have to define a subnet that you're going to use to peer, as in the IP address assigned to your router and the Microsoft router, but you also need to advertise a set of IP address.
Yeah. Okay. So this is essentially like a step 2, which overlays the peer.
Correct.
The peer is set up, the handshake's done, everything's happy. Then you got to do your
Then you got to advertise something to Microsoft through BGP.
Yep.
Right. And you'll see when you configure Microsoft peering in a portal, for example, compared to public peering, there is a third step, which is what are the ranges of public IP address you'd like to advertise out to Microsoft.
So set up right. Okay. Gotcha.
Okay. These IP addresses that you now advertised, guess what? They're going to be used for NAT on your site. Why that? Well, you still need NATing because you're still using a private IP addresses and go convert that to a public to access the services. But this time you cannot use the actual public IP addresses that was assigned to your interface for your peering. You need to use another set of public IP addresses. So in our case here, instead of 103.250.14.0/30, let's say we do a 250/29, for example, a bit larger. Why? So you can do multiple NATing if you want, but you could use a /30 there too, and only have 2 IP addresses if you want, right? Or a /go roam, right? Okay. So actually, that's wrong as well. If it's a /29, getting messy, it's .8. Thank you. Okay, so we're going to advertise this, and our netting is going to be part of this range. So for example, .9 is going to be our first net. So when I'm here, I come here, I get a bit behind that. Now, any services that is now being accessed is going to be accessed with
From
this
there.
IP address.
So I guess the advantage here for the folk is if you're a massive enterprise company and you've got BGP set up for your internet connection, then here's the problem. You've got already public IP addresses advertised to Microsoft just for the internet. You don't want to advertise those through Microsoft peering as well, because otherwise you're going to get potentially asymmetric routing happening.
That's right. And this is where, coming back to what you mentioned at the very start, with public peering and asymmetrical routing, because there was an acting of Microsoft.
And NAT here, so it doesn't really matter.
It was not really asymmetrical, because I could use private IP addresses anyway.
It came back to a single IP.
Exactly right. Now, with this, yes, absolutely. Whatever you advertise here to Microsoft Public, don't get me wrong, they're not going to advertise that further, so they're not a transitional network. So those addresses will stay within the confine of the Microsoft network, okay? But if you're advertising that out to your internet, and you're now trying to access things to the Microsoft network, and the Microsoft network knows two routes to come back,
things may break.
Now you start to look at symmetrical and problems, insert problem here. Okay.
So
now,
just to recap, this subnet here used for peering, and this one used for advertising.
and you need two, by the way, I forgot to say, because you need your primary and your secondary connection.
Yes, of course. Same as the private.
Same as
up
the
here.
private.
Same as the
That's
private
right.
across the two physical connections. So this subnet here, you can use that for advertising as well. You can, because as you said before, you can do
In public.
traffic in public.
Yeah.
Yep.
Public, but you can't do it anymore because you can't set it up anymore.
Right. What about Microsoft peering?
Microsoft peering, you can't.
You can't use that.
No,
right.
you can't use
So
that.
Microsoft peering is the
You
odd
have
one
to
out.
advertise another range.
Gotcha.
If you advertise the range that you use for your peering, you're going to have problems.
Okay.
Okay, so
Why
it's
is
bad. It's bad. I don't know. I've been told don't use that. Slap on the finger.
Okay, so that's
do not
the
use that.
other idiosyncrasy with Microsoft peering. Keep that peering subnet separate to what you're advertising. Right.
That's right.
Got
Now,
it.
I'm sure that if you do advertise that, it might work. It might not work. I've been told don't use it. So don't.
I'll
use
let
it.
you test it later on.
Okay. Now, once we've got, just to finish the story, once we got public peering done, we're going to advertise our range. We're still not going to get anything back from Microsoft until we create what we call a route filter.
Which is basically on the portal side.
On the portal, correct. So on the portal, we're going to go and say, I would like the routes from Sydney and Melbourne, please. Right? Now, some people may ask, oh, great, so now I can do Office 365 peering. No, you can't. Because even if you go and select and tick the box to say, I'd like SharePoint, I'd like OneDrive, etc., the route filter, when you apply the route filter to the actual ExpressRoute, it does verify what kind of access you need/can have. As an example, if you have a standard ExpressRoute, which does not allow you to go in the international zone, so you're stuck within Sydney and Melbourne and Canberra. Actually, Canberra is a different matter. You can only select Sydney and Melbourne. If you select any other zone, any other region, it's just going to bomb you out because you don't have a premium ExpressRoute. You only have a standard ExpressRoute.
Gotcha. Okay, and the other thing we'll just add to this as well, Office 365 prefixes. Previously, when it was Microsoft peering was just Office 365, you couldn't get Microsoft peering unless you got approval from the Modern Workplace team.
That is
now you can get Microsoft peering put in. However, you can't tick or get
tick the boxes for
Office 365 until you get the approval. Right.
Right, but it's a lot easier because it's just literally a
Couple of tick boxes
tick,
and
tick, tick,
away
done,
you go.
and you get your route. One last thing. So, how does that all sit in terms of subscriptions and who can access what within Azure? When we talk about private peering, your peering will be private to within your subscription or whatever connection you establish from one VNet to another with VNet connections. Okay. When we now talk about public, it's not assigned to a subscription. Okay, so if I say I don't have any private, I just do a Microsoft peering, I'm going to get one subscription A and say, well, I'm going to do an ExpressRoute with Microsoft peering with my subscription A, pay for that through my subscription
The
A.
circuit, yep.
But at that point, every single service that is used through public can be used for that ExpressRoute no matter what subscription they sit in, because it's pure routing. Okay, so on your side you get all the routes for public Azure services. Even if you now want to access a SQL database that sits in a complete different tenant or a complete different, that will work. It's just going to route through it.
Makes sense. Yep.
Right? Because it's not related to your subscription, only billing, basically.
Yep.
Okay. Yeah, I think that's about it.
Cool. Alrighty. So Steph, thank you for that. And so do you want to just give people like an idea of like if they want to get hold of you, if they want to ask further questions?
Yeah, so probably Twitter, Stephane, spelled Stephane, the French way, Stephane Budo, @Stephane Budo, or my email address, sbudo@vigilant.it.
So, and you're available as well to help people set this up?
So we Azure experts. I'm an Azure MVP, so of course we Azure
And
experts.
you're a PTSP as well.
And I'm a P-CSA, excuse me, for the least.
Really? You've
yes,
changed?
I am.
You're pretty much part of the furniture here.
That's right. That's right. I even have
A Microsoft Cup. Awesome.
Anyway.
All right. Thank you, Stephane, for your time.
Thanks, Mark. See you later, guys.